So today's presentation is Solve OpenMP validation and verification effort. Now, I will explain what is Solve and what is happening in this project. But we are collaborating with the University of Delaware on this project, and we are trying to develop an OpenMP validation suite. So what is Solve? This is the outline of my presentation. I will explain what the Solve project is, what is the scope of the VNV, what does the suite look like, and what is our design process, and some results, some success stories, and how we would like to collaborate with the community. So this entire Solve project, it has a runtime component, it has compiler component. Solve basically is trying to scale OpenMP via LLVM for exascale. But the VNV aspect of it is implementation agnostic. It does not mean that we are restricted to LLVM specifically. Anyone can use it, and we can help the community at large. So what is the scope and intent of the VNV? We want to verify the status of the OpenMP implementations, more specifically for the ECP exascale platforms, but you can use tests on all implementations on hardware. We want to evaluate the OpenMP functionality and the performance on target architectures. Now, different implementations are at different levels of implementing 4.5, 5.0. I don't know if 5.4 is, it's underway, but I don't think there is a complete implementation out there. So using these tests, you'll get a fair idea of how much implementation has been done, what is remaining, what tests can be done. So we want to check the implementation's conformance to the OpenMP standard. The OpenMP standard itself is humongous, and it was not built to understand, well, it's from a compiler developer's perspective. You can't start writing OpenMP code just by looking at the standard. And we simplify the process. The VNV test suite also you can also look at it as an example base. Though we have an example document, the examples document is not supposed to be exhaustive. This one, wherever we hit, we try to be as exhaustive as possible. And we want to, though it is motivated by ECP applications, like what specific features are important to them, we try to address more general demands from the OpenMP community if you start the conversation. And we want to verify the readiness for OpenMP applications. What does that mean? Now, if you have an OpenMP application and you don't know how this is going to look, how this is going to fare on an ECP platform like Summit or Frontier coming around, you can make a small kernel and send it to us, and we can run them because we have access to all these platforms. We can run them and tell you, okay, this is how it is going to look, or this is conformant to OpenMP, or you need to change this to make this more efficient. So this is one of the uses. This is a diagram that shows how we develop our tests. So we analyze an OpenMP, we take it each directive, each clause. We try to keep the tests as independent of each other as possible in the feature sets. We formulate a test, we discuss its adherence to the specification. As you know, the specification, there are constraints all across the specification. And to surely say that, okay, this is a valid OpenMP program, coming to offloading and things like that, it's difficult. So discuss that. If it is a valid test, we move on to test it with our available implementations on the different platforms. And if the test passes, we put it back in our VNV. If it does not, then we try to figure out what happened there. Is it something to do with the test? Was it a bug in the implementation? And we have found such bugs, and we have reported them to the vendors, and they have corrected it in the next release. So sometimes it's a specification issue in terms of how people understand. Sometimes the implementers understand the spec in a very different way from what a user does. And we try to address this by bringing it up in the OpenMP ARB, the specification forum. So we started the VNV suite at 4.5. So as people might be aware, 4.0 was where OpenMP offload to devices came in, and 4.5 was a refinement on it with a few new features. So we have started developing the test suite specifically focusing on the offload capability, because ECP machines, everyone is going towards the GPU or device programming, and that is important for us. So we started with that, and as we finish 4.5, we'll move on to 5.0 or 5.1, depending on what the vendors deem to provide. So, as an example of understanding the specs, so as we were developing the test, we found out that when we did the array to from, like, it is a very natural way. You would want to only have half of the array. You're dividing up the work and you want to map half of the array here. But what we found out was that's not correct, because there is an implicit mapping on the target which does the entire array. And the specification says that you can't have first map a subset and then map the first. So the overlapping sections does not allow that. You have to, the second map has to be a subset of the first. I don't know if that is clear, but these are the few things that we found out while writing the test. And it was not really explicit in the specification. So this works. When you allot the entire array size and you try to use half of it through a map alloc, that works. So these are typical quirks of OpenMP, target offload, that we are trying to capture, and we are trying to test this in implementations. Now, something about the Ambiguous specification. Now, we found out that you can't have a variable in the shared clause and map it from, and have it in the map clause. There is a specific one line somewhere in the spec that says there is this restriction. To circumvent it, you have to change the thing of scalars so that you can use this, the share scalar, this, in a shared clause. So this is something that a programmer is not going to realize first off without, well, learning the spec from top to bottom. So we look at all these, try to make test cases simple, usable, so that people can understand how OpenMP is used, as well as verify the specification. Now, Jose will take over the rest of it.
So I'm going to try to cover a little bit of what is the infrastructure we are trying to build and how we are planning for the future to try to extend it to 5.0. As Swaroop mentioned, we have started with 4.5 because the moment we were working on this, 5.0 wasn't released yet, and most of the development was happening in 4.5. And we want to make sure that we are getting to a point in 4.5 where we are happy and satisfied with the coverage in order for us to move to 5.0. But we understand how important it is for the vendors right now to obtain 5.0. So we want to use makefiles because it's something that is already available in most of the systems, because it's something that is easily deployed. So we wanted to have multiple options that allows the user to customize the way that we run the test. For example, we want them to be verbose sometimes, or we want them to just be pass and fail. We want them to be, we may have multiple different versions of compilers in the system, so we probably want to support module files. So especially in HPC environments, we will usually have module files, some sort of Lua modules or Linux modules or any of these sort of capabilities. So we extended it to be able to support those sort of files. We wanted it to be flexible with respect to the systems we were using, or with respect to the number of compilers we were using. So what we did was we tried to split up the process in a make-specific part and a system-specific part. So what we do is we have a folder in the infrastructure that is expecting to have the test that we are trying to develop. Within that folder, we need to have the multiple versions. One of the things that we realized here is that it was easier to split up the test of 4.5, 5.0, and any other implementation in the future, because sometimes there are slight changes that make some of the tests that we have developed for 4.5 not valid anymore in 5.0, or not valid anymore in the future. So trying to be incremental with respect to OpenMP resulted to be more complicated than just trying to build one particular implementation. There may be tests that will be duplicated, of course, but most likely the parts where it's conflict, we will not have to go and cherry pick those parts and try to figure out how to organize it in the source code or somewhere else. So inside, we divide it up into multiple directives. And for each of the directives, we have a different folder. We have the different that we have. On the other side, we have a folder inside of which we keep a systems folder where we are allowing the people to specify a particular flag that they want to be for systems or particular compilers that they're working on so they can extend the available compilers. We don't want the user to always have to go and specify all the flags that you need for OpenMP, especially for uploading, because, for example, in GCC, you have FOpenMP, FNOpenMP offloading, then you have the type of target you're having, and then you have probably the linking of the offloading part, the linking of the host part. So it becomes a really big and verbose command lines. So what we want to have is we want to have everything built in and trying to support as compilers as we can from out of the box, but also allow the people to extend that. So in a recent commit that we had, we started supporting AMD AOMP that has been released many times, and I have results for them. But now, if somebody wants to use that, they just have to download it, and most of the flags that you need for AOMP are already embedded in there. So in the system file, what you will be able to do is extend all of those simple cases. So, for example, for the module files, we are not going to be able to know what are the actual name of the modules for each of the compilers. So there is an option where you can specify what is the name of the module, and every time it will run a test, it will load the module to make sure that that is the particular context that you want to be building, working on. There is also a template folder where we keep all the uses of the all possible. So whenever we were making the infrastructure, one of the things that we did was trying to standardize the way we output about the test. So whenever we are running a test, we want to always have the same sort of message. We also want to know what file created the message, what line in the file created the message. So we created a header file, and in the template folder, you can see all the possible uses of that particular header file. And the header file is usually stored in the OMPVB. And the idea of the header file is to be able to standardize the way we show the output in the test. Okay? So currently, we have a website where we manually, right now, we are trying to go into continuous integration, but manually right now what we do is every so often we update the results on the systems that we have. Right now, you can see more than 1,000 runs in there because we have been running it on multiple versions of GCC, we have been running it on multiple versions of Clang, we have been running it on multiple systems, so we have Summit, we used to have Titan before, so not anymore. So we have been always trying to expand as much as possible in between vendors and in between different systems, because we have also realized that when you stay with a single implementation, you tend to get biased to that particular implementation. And we have noticed that sometimes we are not able to catch bugs on our test, and then somebody else that is working on a completely independent compiler comes back and they are like, look, the specification actually says this. So we go back and have to refix the test, right? So the cycle that Swaroop was showing at the beginning is actually something that we sometimes have to redo, or even on tests that we already have. So what I want to say is that please visit the website to make sure that you will get all the output. You can see what compiler generates the output. You can see how to collaborate. Some of the things that we have been trying to keep track of is what are the bugs that we find. But this is also a process that each vendor has a different way to communicate with them. So we try to summarize where we have the things, also in the specification. So another example of an issue that we have found, or not an issue, but something that created a special discussion in the specification was we realized that the interpretation of the number of devices can be different if you are considering the host as a device or not as a device. And so probably somebody that had one GPU and one CPU will result into obtaining two OMP num devices. And so it becomes a question of what do we do with respect to that number. So we raised that question into a specification. The specification came back to us saying we have to be more clear about this. And so most likely this is going to alter the way 5.1 or the way 6.0 is released. So we try to keep track of this. This is mainly for our bookkeeping, but there has been many cases where we submit bugs. We have submitted bugs to IBM. We have submitted bugs to LLVM and to GCC, and we are trying to always increase the number of compilers that we use. We know, for example, that there are several vendors that are right now interested and that are using the test suite for their own tracking of their own bugs. For example, for regression testing. We also have a lot of interest in, because we are part of the ECP project, we have a lot of interest in the new systems to be able to use this as part of the validation process of new systems. So I think that what we are focusing on a lot is trying to build that infrastructure that allows multiple people from multiple sites to contribute to us and try to keep it as vendor independent as possible. So for example, some results in Summit, there are multiple ways that you can run this. These are results for GCC, IBM Excel, and LLVM compiler. In Summit in particular, there are two versions of LLVM. One is the 9, the trunk version. The other one is the Coral or the YKT version of LLVM that is also available to download. So we have been able to try those to try our test suite on those two. And we see, for example, that if you were to stick only with an IBM Excel, you'll see that all of it passes. But whenever you move to another one, sometimes they fail. So, for example, IBM Excel supports C++ classes almost out of the box in OpenMP 4.5. But there are elements that are extensions on the IBM compiler that are not necessarily supported by the specification itself. So if we were to stay only with the IBM, we wouldn't find out that some of the tests that we created in the past that were using C++ classes had to be modified in order to be compliant with 4.5. We have also run it on our own systems, and in this we try to summarize all the different versions that we already have and that we are allowed to publish right now. We have Clang, we have GCC or GNU, we have AOMP, we have XLC, and we have the Coral Clang. And in all of them, we see that there is still some room, and sometimes these vendors are contacting us saying there may be things in our test that we have to look up for. So what I'm trying to say here is that if you are a user of our test suite and you find out that there is something that you want to discuss with us, we are always open to that. Okay. For example, in AOMP, AOMP has multiple releases already. So we have from 6.2, 6.3, C4, 07, 0.01, all the way to the most recent release, 7.5. And there has been some improvements that I have there. We recently had a conversation with them. They said, we have some comments for you. So we are already having conversations with them, and we want to see if this is something that we have to revisit or if this is something that they have to revisit. Okay. And also, maintaining this amount of compilers tend to be difficult. So it's not only about writing the test, it's also about trying to come up with as many systems as we want, with as many compilers as we can. So we are also trying to meet with vendors to see how we can make this process a little bit more smooth for us as well. So there are some success stories. For example, AMD and Cray has already told us that there is they are using this. Intel has already told us that they are using this for their own compiler development. So there are already vendors that are interested. Most of them, the major criticism is the amount of tests that we have, and our major message for them is we need as many hands and eyes on this because it's really hard to keep everything together with our effort. So we want this to be a community effort, and we want to have as many people as we have. And so for that reason, we try to specify how the collaboration happens. We are open to issues, we are open to pull requests, we are open to communication, or to having meetings, or whatever any of the compiler vendors want. So yeah, I think that our project has started to track attention, and we just want to make sure that we remain as the option for this. And we want to always continue being vendor independent, because vendor independent, we do not want to reach the testing that each of the vendor has, because they still need that for their own development. They still need to create their own tests for their own development. But that test that they are creating will be biased to their own particular implementation. And we want it to be something that we can make sure that the specification itself is clear, that we can all agree with respect to how to interpret things. So if you want to collaborate, you can go into our GitHub, you can create issues. If you don't have time to do a PR, you can say, hey, why don't you look at this particular test? You can do this. Or if you try it on a particular system, for example, we had somebody from NEC using it on the Aurora SX system. Well, you are using too many threads, and it's hard for us. So right now we are trying to improve that, so we make sure that we are also useful for them. So just come into our website and make sure that you give us comments or whatever you need. So if you need to check the status of our implementation, you can go into our website. If you need to check the status of some particular implementation, go into our website, go into the results. You can filter by system, you can filter by compiler. You can click on it. It will pop up a new window. It will show you what the output was, what was the issue. If you need to check your own OpenMP, you can obtain the Git repo and run it yourself. There are already instructions in our website on how to do this. And if you have a problem or you want to mention something, you can either submit an issue or create a PR, and we will be happy to take a look at it. And if you find that something is missing, please submit an issue or create a PR and communicate with us. We are trying to be as open to the community as possible.